So in this video we're going to take a look at some more examples of rearranging formulae, and in our first one we've got a equals pi r squared and we want to make r the subject. So a equals pi r squared. So we want to isolate the r, so first of all I'm going to divide by the pi. So a over pi is equal to r squared, and then I can square root both sides to get myself r. Now when I square root both sides I'm going to get a plus minus, so I'm going to get the square root, plus minus the square root of a over pi is equal to r. Now you might be wondering why I'm including the plus minus here, because you might be thinking that this is area equals pi r squared, so the area of a circle. Now it may well have that context, okay, but I can't give it that context. It doesn't necessarily have that context. A might not be area, r might not be the radius, okay. So if it was, I wouldn't have that plus minus, but because there's nothing attached to it, this is the rearranged form where r is the subject. Okay, so we do have to be a little bit careful about, you know, giving something context when it doesn't actually have any. So the second one, we have v squared equals u squared plus 2as. This is actually another of the constant acceleration formulae, the Suvat formulae. And we will need to make u the subject. So we want to get u squared by itself. So I can subtract both sides by the 2as. So v squared take away 2as is u squared. And then I can square root both sides to get myself u. Again, context aside, that will be the plus minus the square root of v squared minus 2as. So square root the whole thing. Be careful not to square individual pieces, okay? That's not how it works. You must square root that whole thing. So u is plus or minus the square root of v squared minus 2as. Okay. So that's number 2. Number 3, g equals hy cubed. Now I've been asked to make h the subject of the formula. So actually all I need to do is divide both sides by the y cubed. And that will leave me h. Okay? And so that is number 3. Number 4 looks very similar. V equals a m cubed. And we want to make m the subject. Well, because I want to make m the subject, I need to divide both sides by a first. And then I can cube root both sides. Now the cube root doesn't bring in a plus minus. The 4th root does, the 6th root does, the 8th root does, but the 3rd root, 5th root, 7th root doesn't. Okay. So when I cube root, there's no plus minus at the front like there is for square root. So m is equal to the cube root of v over a.